Well, hello everybody, and welcome back. It's good to be with you again. I hope you enjoyed your break. I just had gummy bears for lunch, so now I feel like I'm all set, right? Let's begin. So the internet has, of course, revolutionized commerce and communications, right? We know this from this course, from other courses, from our life's work at present. And web applications or web servers are widely used, right? And so normally a web application is supported by a web server that runs a general purpose or embedded OS. Now, each component, the application, the server, the operating system, it has its own vulnerabilities, right? And we've seen throughout this course that when combined, there is an increased risk of compromise affecting a network's overall security. So skilled hackers can often exploit it and use these things as stepping stones to launch additional attacks against the OS. So these are the objectives that we will be looking at today in this chapter. Now, writing a program without bugs, I will say, and you know, really very difficult, right? The more people who have access to a program, the bigger the risk of security vulnerabilities, right? And so this is something that we want to watch out for, right? We know it's a major attack vector as security testers, right? And so as a security tester, this is the kind of thing that we can face when we enter into a company, right? So they might say, you're new to a company, they just hired you as a contract to do some security testing for them. And now management wants to protect all the traffic on the company's HTTP or HTTPS server. So you've been asked to recommend a solution, right? So which device would be the best solution? And you should pause the video now and think about it for a moment. Okay, well, welcome back. I hope you had a chance to review it. So the best solution to protect all the traffic on the HTTP or HTTPS server is a web application firewall. A web application firewall can be implemented in hardware or software form to protect a web server from, say, a cross-site scripting attack. So a web application firewall, or sometimes I'll just call it a WAF, right? Provides security at the application layer. That's the layer 7 of the OSI model. None of the other solutions provides that same level of security as a web application firewall. The network firewall would be able to provide some protection, but it provides more services than you really need. In addition, because the network firewall protects the entire network, its performance could be degraded, right? So an intrusion detection system does not really secure devices. By definition, we know an IDS detects intrusions and sends out alerts when the intrusions occur. And remember that as security professionals, we should always want to keep a defense in depth or layered security approach in mind. Physical security is often considered the first layer of security, and it includes any mechanisms that protect the physical security of your facility, for example. And so, however, physical security is not enough, we would agree, to completely protect your assets. Once the physical security is covered, then the perimeter security and internal security should be assessed. That's a good three-step approach. So the last three aspects of defense in depth then are host security, application security, and data security, right? And so personnel decisions, they encompass all these layers as a security tester. Personnel can affect any layer of the defense that we are looking at. And so training personnel is key. Security to security, right? To make sure that we're not compromised. Okay, I thought that was interesting. I hope you did too. So web application components are here. So HTML is, as we know, the foundation of most web applications and is commonly used for creating static web pages. Right? Now, these static web pages, they display the same information, right? It's static. It's not moving. where dynamic web pages can vary, which is exciting. For web pages to be dynamic, though, they need special components, as you know, including the form element that you see in the last bullet on the slide. They might need AJAX. They might need a common gateway interface. Active server pages, which is ASP, PHP, Cold Fusion, or JavaScript. We're going to discuss all of those in the conversation today. Now, so the web forms are used in this approach in an HTML document to allow customers to submit information to the web server. And the web server then is going to process that information from a form that you inserted using the web application. This is all very important because it seems simplistic enough, but these are attack vectors that we are considering as security testers. This is an easy way for attackers to intercept data that users submit. And so security testers should recognize when these forms are being used and what measures were taken to protect the forms. We're going to talk about those mitigation approaches too, right? So in these web forms, we want to make sure that the software vendor or the company, if it's building its own apps, use secure DevOps or DevSecOps, right? That's security development operations. And what that means is that security is built into the development of the application and hence into your operations. Now, baselining allows you to know whether software or hardware, for that matter, performs under normal load conditions, right? So you want to baseline an application. You want as part of DevSecOps, and so, but that behavior, baselining in this case, is known as metrics, right? So when you add new services, you are now able to determine what effect those services have on system performance, right? Because baselining is passive, it would not allow you to configure or manage, for example, data centers. So mitigations in this approach are many. For example, you will want to ensure that your code undergoes multiple levels of tests, right? You'd want to do static testing, right, of the basic code. You'd want to then do also dynamic testing, sometimes called fuzzing. So dynamic testing is the code in operation, right? So you get a different result than in the static environment. And then a special use case of that is fuzzing, which is input validation. You actually make inputs and validate that your application accepts it or addresses it. This even, for example, you could use code reuse. If you have code that you know is good and it's proprietary in your own company, reuse it. Right? You want to do error handling so that if somebody makes an input, that your application doesn't crash, that the application catches it, error handling, and gives you that error message, right, to keep the application running. Because once a system is allowed to crash, that's when code can be injected and hackers take over. Follow data, watch data, insert backdoors through malware, and etc. At privilege escalation, etc. Now, a common gateway interface, or CGI. I mentioned this a few slides back. So this is another standard that handles the moving of data from the web server to the web browser. That's called a CGI, right? Common Gateway Interface. And this enables these dynamic HTML web applications, right? So what I mean is that this handles the moving of data from the web server to the web browser, right? So CGI is that interface that determines how the web server is going to pass the data to the web browser. The main role of CGI is in passing that data. And in fact, the term gateway describes this very movement of data between the web server and the browser, right? So if CGI is implemented, then scripting language compiling may not be necessary, right? Which can be a goal. Notice that CGI is also written in various languages. It relies on C or C++ and Perl or other scripting languages that use dynamic web pages, right? So now the Common Gateway Interface, as mentioned, CGI is implemented with the scripting language, and compiling isn't necessary, right? So compile time is the time in which the source code is converted into an executable code within the runtime, right? And the runtime then is the time that at which the executable code starts running. So compiling it is different than runtime, right? In a compiled language, the target machine translates the program. In interpreted language, the source code is not directly translated by the target machine, right? Which I think gives you much more control over your software. The source code, again, is not directly translated to the target machine. So instead, a different program, like an interpreter, is going to read and execute the code for us. Now, there are third-party frameworks that are also part of this that we want to be aware of. Third-party frameworks and libraries. So frameworks are typically called on for a specific purpose, right? To enhance the user experience, for example. You may use libraries, which saves developers a lot of time. That would be a third-party part of a third-party framework is using libraries. But this also creates, we recognize security testers, dependencies, right? So, and that's something, in fact, let me tie it to our discussion of CVEs back in Chapter 8. If you don't recall CVE, flip back to Chapter 8. So an infamous example of an Equifax breach was enabled by a vulnerability in a commonly used dependency of Apache Struts. Struts is a web application framework for developing some Java applications, right? And in 2017, CVE 2017-5638 was reported. Good. System's working. Now, the vulnerability was fixed in a newer version of the software. Good. The system is working. But as discussed, many companies don't keep track of their dependency versions and vulnerabilities, potential vulnerabilities. And so after being known for months, the company Equifax, right, one of the largest credit reporting companies in the United States, had a breach which leaked, amongst other things, 200,000 or more credit card numbers. And so the attackers, they used CVE 217-5638 vulnerability, and which meant that an unvalidated input or unchecked data could be sent into the system. This, in essence, is a form of injection and one of the types of common vulnerabilities. You can read more on that yourself, right? It's just a good way to understand how how frameworks and third-party libraries can impact our decisions or open us up to vulnerabilities within companies. The security testers will want to keep an eye on that. One of the things you'll want to ask is, where's your version control for updates compared to known vulnerabilities? Okay, let's take a break there and we'll come back shortly.